screen, and so you can see this is a handout, and so all these handout, this geometry in the handout is given in the English unit. So we can go to parts here, and part 1, and 3D deformable solid extrusion. We can just use the approximate size 50 because we know the length is 10, and also the outer diameter is 10 inch also, and it's safe for us to use 50 as a whole and whole page. So, and then we draw the circle. And when you draw this one, you need to be very, very careful, right? So we draw 2 circles first, and 2 arcs. So this is the center. Okay, this is one arc, second arc, the same center, but this time is here. Okay, now we draw this as 2 arcs, and then we can dimension it and be very, very careful. Dimension it, and we may dimension this biggest one first, and its default value is R7 inches. And because we know it is a 10, and we just modify this one to 10, and then we can dimension this is an inner arc, and so this is default value is 3, but we want this guy to be 5. Now we have this is 2 arcs, and then we draw a vertical line. And we draw another line. Oh. No, okay. Just 1 second, let me. Be very careful when you draw these things. Okay. And then here is a vertical line also we need to draw. And then we just escape. Now we can dimension these lines. So this line is, we enter 10. So this is 10, this 10, this is H, this H will be 5. We can just take a look. We can see, right? 5, see, you can see it's 5. So we don't need to enter it. You can enter if you want. So this one we don't need to enter. It is a V, we know this is a circle. Now we have finished dimensioning all these edges, and we can select this one and then done. So the depths and dips we use a very, very slight, very thin one, 0.1. 0.1. We click OK. Now, so you can see this is a very thin slice. And then we define the materials. Thermal, click thermal here and enter the conductivity. And conductivity value is 8.09 power minus 4. And then we click OK. And then after we finish this one, and so we just create a section. And based on this solid, homogeneous, continue, and based on material 1, and say, please do not select plane stress or plane strain. Now see, we have created one section. And then we go back to this material to assign this section to this material. And select the whole body, whole region. Done. Oh. Just one more time. Select the region. And done. Select this section 1 because we only have one section. So this section has been assigned to this part. And then we create assembly. Go to assembly here, distance. Part 1, we say create a part 1 and be sure, make sure that we toggle this on independent because this is give us convenience when we mesh it. It does not matter if you do not toggle this on. If you click this one, and later you can come back and to change. Click OK, and then we'll go to the stamp. Click this stamp, and in this stamp we can enter heat transfer steady state. And the initial step is created by the system automatically. And for this case, we will say, and this is select heat transfer procedure type. The procedure type here, we select heat transfer, and then continue. Click continue, and make sure steady state response here. Here, make sure the steady state is selected. So default heat load variation with time has been changed for ramp linear overlap. Okay, dismiss. And then click OK. And then we apply boundary conditions. And go here and don't forget to save it. Save. And so I will say heat transfer, and let's say thermal analysis, demo. Okay, we go to boundary conditions. Boundary condition, and we have inner temperature. Inner temperature. We assign this inner temperature to inner arc and inner and street surface. And how to do that? And we use the shift key. Let me rotate this one a little bit, so I can select this is inner edge, and edges more easily. Just 1 second, and then I can enlarge. Then I can rotate a little bit more. Enlarge. Now I can click this X here. Now I can use the shift key. Okay, use shift key. That means you can select multiple items. So here, make sure this is selected. Yeah, it's temperature. Okay, temperature. Then continue, and then select region. This region, we enlarge it. Make sure this is this region, and then we just pan it a little bit in order to select this is a split edge, and then we enlarge it, and we use the shift key X, shift key here, and then you can just use this one. Make sure see both of these two segments are selected, and done. And the magnitude we use 75, and then click OK. Now see, you can see this boundary condition has been assigned on these two segments, and then we do the same thing. Click the boundary tool we call outer temperature, and also temperature. Continue, and we are asked to select regions for the boundary condition, and we need to select this outer one and the outer arc and outer this is straight line. And in order to select them, we need to rotate a little bit Then we enlarge it, and then we X this one, and we just use the Shift key. We enlarge it a little bit further. We use the Shift key. Okay. And then we just pan it a little bit, and to make sure we can select the straight one. And also use the Shift key. And make sure you are selecting this is the very, very narrow surface. And then we click done. And now this time is 40 or 0 Fahrenheit. Click OK. And then we can use this one, Alt Fix View tool, and to see. So you can see it is boundary conditions have been assigned. And now this is kind of the orientation is kind of weird. And in order to see better orientation, and we can go here, View, and this one's viewport. No, just 1 second. Toolbar. Click this one. Click this view. Then this one will appear. You can just put it here. Why this one? You can see X, Y. You can only see this X, Y. This one, we can see it more clearly, right? So make sure you save it. Under boundary condition, also make sure boundary condition 1 and 2, and start from step 1. Let me right click this one, manager. Yes, from the start of heat transfer created and created from here. So this is because the steady state of the heat transfer. And then we do the apply the load. Go here, double click loads, and then this one appears, and we see heat flux. Oh, geez. Heat flux. Surface heat flux. Then click continue. Now it also say select the surface to outer arc and outer straight line. And we need to rotate a little bit, and then enlarge it. And then we pan it, and you need to use the Shift key, right? And then click continue. Now, the magnitude, the heat flux magnitude is 2e minus 4, 2 power minus 4. Click OK. Now, then we can use this auto fit view tool and to see. And use this one. So you can see this is the surface heat flux. Then we save it. Meshing. Now also make sure the load starts from step 1. Load from step 1, yes, from the heat transfer, which is step 1. And then we can mesh it. So you see, please do not use free meshing. Okay. So goes here, mesh with seed, and see the edge. So here, select the edge to be seed side. by number. And so for this edge, this edge, we want to use 10. So this edge, we want to use 10 also, because it's 5. So this edge, and we use 20 because it's a 10, right? So the length is 10h. So this edge, and we use 20 also. So this is arc, because arc we need to use finer mesh, and so we use 20. So this arc, we also use 20. Now we have done, right? And then we can use this icon, assign mesh control, and we use hex, sweep, technical, use sweep and advancing front, and then we click OK. And then assign element type here. Element type, we use the standard, quadratic, for geometrical order. So this is the polynomial order, and heat transfer. And we just go here, family, we need to find heat transfer. And now we click OK. And then we mesh it, and we use this icon and to mesh it. Now this is my my first mesh, and save it. Then we create a job. We create a job, and don't use job 1, job dash 1. Okay, I want you guys to select this one. So if I were you guys, I will write this is a thermal underscore analysis. 1 means that for my first mesh, the causes mesh, and then click OK. Okay. Now I have created this job, then I can just submit it for running. So this dialog appears. Heat output is not required, and we did not require the heat output. If you want, you can require, but I did not ask you guys to do that. So you can click OK now, and then this is submitted, and so usually it runs very fast, and you can get the results very quickly. See, it's completed, and now we can visualize it. Results. So thermal analysis demo. We want the demo. Thermal analysis -1 ODB. Okay, so this is our results. We can use this one to see. So define the path. Here I'm going to show you define the path, guys. So path here, and actually this is our old friend. For the plate with a hole, I taught you how to define a path. Now I'm going to teach you again. Path, and let's see the bottom, the path 1, okay? And we just on the handout, I ask you guys to use node list, but now I want you guys to use, and this is edge list, right? Use edge list, and continue, and click add before. And for your convenience, just move this one a little bit up here, and now you can select edges, shift the key. I'm sorry. No, I'm sorry. Let me redo it. Path 1 edge list. Continue. And before here, select by feature edge, and use the shift key. So all these lines, all these nodes on the bottom edge will be selected. Done. and OK. Now this is my path. And then we can go to the XY delta, and based on the path, continue. And path 1, because we only have one path now, deformed true distance. And here, field output, and you can select which one you want to visualize. I can suppose I want to visualize nodal temperature, and you can just click OK, and then you can plot. So this is the curve. I want to see this one. I want to plot. This is my plot. Now you can select and the variables that you want to display. This is how to do the cost. Another thing I want to teach you is that here is a plug-in, okay? So some students say, Dr. Ma, how can I just output this is the data, say some students say, Dr. Ma, this Abaqus is very powerful, but this picture is not what I wanted. So how can I output this data into the Excel? And you can use this one, plugin, Abaqus, tools, so Excel, utilities, and then you can select, this is so this is the data, all right? So this is the data, and we have temporary. You can change this one name, and so you can see. So this one will be the temperature, the Excel file. So this is a very good tool. There are several things I want to teach you guys. So there are several things there.